Hello folks, this is the question for 2018 May-June paper 2-3 and the question number is 6. It is again concerned with current electricity. It says that wire X, which is shown here, has a constant resistance per unit length of 3 ohm per meter. So in symbols it is equal to R by L is equal to 3.0 ohm per meter, and a diameter of 0.48 millimeter. So D is equal to 0.48 millimeter, which is equal to 0.48 into 10 to the power minus 3 meters. We have to find the resistivity of the metal constituting wire X. So what we have is rho should be equal to RA by L equal to R by L into pi d square by 4. So this will give us it is a 3.0 into pi is pi, this is into 0.48 into 10 to the power minus 3 square, and then it is 4. So the calculations will give us the value. So 3.0 into we have pi here. We have to use the value of pi, so let me search for pi. So shift to pi divided 4 equal to into 0.48 exponent to minus 3 square equal to, so this thing is equal to 5.43 into 10 to the power minus 7 ohm meter. So the value of resistivity becomes 5.43 into 10 to the power minus 7 ohm meter. Now number B, the wire X is connected into the circuit shown in figure 6.1. so it is in parallel to this R, and this whole arrangement is connected to a cell with internal resistance 2.0 ohm. So this shows the cell with the internal resistance, and the current given by the cell is 1.6 ampere. So it says that the battery has an electromotive force of 5.0 volt shown here, and an internal resistance of 2.0 ohm like this. The wire X and the resistor R of resistance 4.5 ohm are connected in parallel. The current in the battery is 1.6 ampere. So we have to find the potential difference across resistor R. One thing to remember is the PD across this R is also equal to the PD across this X, or we can say it is equal to the PD across this whole combination. So we can consider this thing as a cell here, then we have the resistance here 2.0, this is 5.0 volt, and this is the combined resistor, this R. This is the combined resistor R total, let us say R total, and we have to find the PD here. And this is the whole cell with the internal resistance. So this thing is the terminal PD for this cell. So the formula for the terminal PD will be equal to E minus I into small r, where small r is the internal resistance. So that's why this thing will be 5 minus current is 1.6 ampere, so it is 1.6 into small r is equal to 2. So this will give us, so it is 5 minus 1.6 into 2 equal to, this is 1.8 volt. So this is 1.8 volt. The potential difference is equal to 1.8 volt. Now in the another page we have now it says us to determine for wire X, we have to find the resistance the resistance of wire X. So what we need to find here is, first to find this total resistance. First we have to find the total resistance. This is obtained by the PD here from the PD and this current here. So what I have to do is, the resistance total should be equal to V terminal, which we just got, by the current here, total current here. So that's equal to, V terminal was 1.8 volt and the current was 1.6. So the total resistance should be 1.8 divided 1.6, and that's equal to 1.125 ohm. So this is the total resistance in the circuit. So now with that, we can find this X now. So we have 1 by 1.125 should be equal to 1 by X plus 1 by 4.5. 1 by X plus 1 by 4.5. So this will give us 1 by X is equal to 1 by 1.125 minus 1 by 4.25, and this will ultimately give us, so we can do this in the calculator like this: 1.125 reciprocal minus 4.5 reciprocal equal to, this thing is the reciprocal of this X. So when I do this reciprocal once again, X will be equal to 1.55 ohm. So the value of resistance in wire X is equal to, it is 1.5 ohm. Now comes its length. So since we are given that R by L is equal to 3.0 ohm, which means R is equal to 1.5 by L equal to 3.0, which gives us L equal to 1.5 by 3.0 equal to 0.5 meters. So the value of length is equal to 0.5 meters.